Welcome to my channel. In this video, I will discuss how to write the laboratory manual for frequency response of RL and RC circuit. So, if any BTech student is watching this video, they must know how to copy the manual in their notes. So, in the second slide, you can see this is looking like a notebook. These are the right side pages. This is the left side page. In the right side pages, you must write whatever I have shown here on the right side. So first of all, you must start with the title. You must write the date and experiment number. Later, you must write aim, apparatus required, theory, procedure, formulae, calculations, theoretical proof, practical proof, precautions and results. Only on the right side pages in your observation or record, and on the left side pages of your observation or record, you must draw the circuit diagram, tabular columns and model graphs. So all these should be drawn only on the left side pages, and this content should be written only on the right side pages. So let us discuss the manual. Let us start with the title. So the title of this manual or the experiment is Frequency Response of RL and RC Circuit. You can pause the video if you are copying it down in your notes. You can pause the video and you can copy it down in your notes. So the aim of the experiment, I have categorized it into two parts. Why? Because this manual has been prepared for hardware experiment as well as for software experiment, MATLAB software experiment. So the first part is to plot the frequency response of RL and RC circuit for sinusoidal inputs of different frequencies using hardware. Second part is to plot the frequency response of RL and RC circuit for sinusoidal inputs of different frequencies using MATLAB software. You can pause the video and write down the aim in your notes if you are copying it down from here. Next, apparatus required. So apparatus required for the hardware experiment. So the first column should be the serial number, which I have not drawn here. You people can add one more column here and you can write the serial number. From the second column onwards, the name of the equipment, range, type and quantity you must write. And the name of the equipments that are required here are signal generator, CRO, decade resistance box, decade inductance box, decade capacitance box, ammeter, voltmeter and connecting wires. So the signal generator or function generator that is required here, its range is from 0.1 Hz to 10 megahertz and the quantity required is 1. CRO that is required here, its range is 20 megahertz and type of the CRO that we require here is dual channel type and the quantity required is 1. Decade resistance box, we need 1 quantity. Decade inductance box, we need 1 quantity. Decade capacitance box, we need 1 quantity. We need ammeter of range 0 to 25 milliamperes, type rectifier type, we need 1 ammeter. Voltmeter of range 0 to 10 volts, rectifier type, we need 1 voltmeter. And connecting wires as per the requirement. So the quantity required is required number. So connecting wires quantity is never specified. You can pause the video and copy down this table in your notes. So always apparatus required for electrical laboratory experiments must be in the tabular form. So for doing the software experiments, apparatus required, of course, we need only MATLAB software. So therefore, software required is MATLAB. So let us see the circuit diagrams. So actually no need to draw the circuit diagrams. You can skip this, and no need to draw the theoretical circuit diagrams which I have mentioned earlier. No need. So directly we can start with the practical circuit diagrams. So circuit diagrams, you can draw this circuit diagrams for hardware experiment. Okay, for frequency response of RL circuit. So this is our R of 100 ohms and L of 0.05 Henry. 0.05 Henry, if you are in your decayed inductance box, if you are unable to set the if you are unable to set 0.05 Henry in your decayed inductance box, what you can do is you can convert that into millihenry. 0.05 Henry is equal to 50 millihenry. So RL are connected in series. Input terminal of R is connected to signal generator. The output terminal of the inductor is connected to the ammeter. So whatever voltage that you are going to give to RL circuit, that voltage is given by using this function generator or signal generator, and how much voltage that you are going to give to this RL circuit, that voltage is measured by this rectifier type voltmeter whose range is 0 to 10 volts, and the ammeter will measure the current flowing in the circuit. The ammeter range is 0 to 25 milliamperes, which is rectifier type. Okay. Now frequency response of RC circuit. To determine the frequency response of RC circuit, this is the circuit diagram. You can see R of 100 ohms and capacitance of 0.2 microfarad. They are connected in series. Input terminal of R is connected to signal generator. Output terminal of capacitor is connected to an ammeter. So the voltage of the signal generator is measured by a rectifier type voltmeter of range 0 to 10 volts, and the output current flowing in this circuit, that current is measured by this ammeter of range 0 to 25 milliamperes, which is rectifier type. You can pause the video and copy down this circuit in your notes. So these two are the hardware experiment circuits. Now let us see the software experiment. So I have written a program for the software experiment. So CLC, the program is CLC semicolon. CLC means clear the screen. Clear all means if any other whatever data is there in the workspace, that has to be cleared. And close all means if any other script is open, that script should be closed. Okay. And R equal to input, enter the resistance value. L equal to input, enter the inductance value. V is equal to input, enter the input value. Input voltage. And F is equal to, F is the frequency. So frequency is equal to 10 colon 1 colon 1000 semicolon. So here frequency is our initial value of frequency is 10 and final value of frequency is 1000, and in the multiples of 1 we are going to vary the frequency from 10 to 1000, and omega is the angular frequency. Here this is our omega. So if you want you can write this as omega, but I have written it's okay. So this is our omega, which is so this is omega, which is our angular frequency, that is equal to 2 into pi pi into f, 2 pi f semicolon. So you can pause the video and copy down this program. Still continuation is there in the next slide. Next, XL, that is inductive reactance, is equal to 2 pi f a l, that is XL equal to 2 into pi into f into L, 2 into pi into f into L. M is equal to XL dot by square root within brackets, 2 brackets, you can see 2 brackets start 2 brackets, r to the power of 2 close the bracket plus again start the bracket, XL dot to the power of 2 close with double brackets and semicolon. So you will put the dot whenever you have to, if those terms are repeating again and again for all the values of, you can see XL is equal to 2 pi f L, and we know f is varying. There are many frequency values. So for each frequency XL has to be calculated. So there are as many f values, as many as f values are there, those many XL values will be there. So for each and every XL value we are going to get the m value. So we have to calculate the m. M is the magnitude. So after calculating magnitude, we have to determine the gain. So gain formula is gain is G is equal to log m. Okay. Okay. So gain is log m, and gain in decibels. Here I have not written, but capital G is the gain in decibels. That is equal to 20 into 20 dot into G. Okay, 20 dot into G, that is our gain in decibels. Now plot omega and gain in decibels. Omega is the angular frequency, G is the gain in decibels, and grid semicolon, X label angular frequency and Y label gain in decibels G. So angular frequency, you can add one more thing here. So angular frequency within brackets W, you can add this. So for gain in decibels within brackets we have written G, so it's better to write angular frequency within brackets W. So it's not W, but in MATLAB you won't get the omega symbol, you have to type W only. You can pause the video and copy this program in your notes. Now let us see the program for frequency response of RC circuit. Program for frequency response of RC circuit. So CLC semicolon, CLC means clear the screen. And next, clear all means if there is any data in the workspace that has to be cleared, and close all means if any script is open, that the script will be closed. Next, R resistance, R equal to input within brackets enter the resistance value, bracket close semicolon. C is the capacitance. C is equal to input. Within brackets, enter the capacitance value. Close the bracket, semicolon. Next, input voltage V is equal to input within brackets, enter the input voltage, bracket close, semicolon. And F is the frequency. F equal to 10 colon 1 colon approximately 10 lakhs. I have taken the frequency range of 10 lakhs. So the frequency will vary from 10 to 10 lakhs with one's division. So with the means after 10 the second reading is 11, 12, 13, 14 up to 10 lakhs. The frequency will vary. And we know that if we know the frequency, you can calculate the angular frequency. Here W means omega is angular frequency. Omega equal to 2 into pi into F. Now capacitive reactance Xc is equal to, I have started the bracket. So bracket start 1 dot divided by, again bracket start 2 into pi into F into C, double time bracket close, semicolon. And magnitude formula is M equal to Xc dot by square root double bracket start R dot to the power of 2 plus Xc dot to the power of 2 double bracket close, semicolon. So actually I have written dot here. R dot to the power of 2. So resistance is not going to vary with respect to frequency. Even if this dot is not there, you will get the response. Okay, so even if you put this dot, even if you remove this dot, it doesn't matter. But this dot should be there because for different frequency values, you will get different Xc values. So pause this video. Pause the video and copy the program in your notes. Continuation. G is equal to log m semicolon capital G, that is gain in decibels, is equal to 20 dot into G semicolon plot omega comma or W comma G grid semicolon. Next X label angular frequency semicolon, Y label gain in decibels semicolon. So you can copy it down. If you want, you can add here within brackets W, and here again you can add within brackets capital G. So you can pause the video and you can copy down this rest of the program. So MATLAB programs, MATLAB software circuit diagram should be drawn on the left side, but the program should be written on the right side. So let us see the observation table for hardware experiment. So frequency response of RL circuit. So in order to determine the frequency response of RL circuit, this is the tabular column. So oscillatory voltage V, serial number, oscillator voltage V, current I, frequency F, angular frequency omega 2 pi F, magnitude M equal to XL to the power of, XL by root of R square plus XL square. Gain in decibel G equal to 20 log M, where the base of the log is 10. You can pause the video and copy this tabular column observation table in your notes. Now let us see the observation table for frequency response of RC circuit. So serial number, oscillatory voltage V, current I, frequency F, angular frequency omega equal to 2 pi F, and magnitude M equal to XC divided by root of R square plus XC square, gain in decibels G equal to 20 log M. You just pause the video and copy down this table in your observation. Next, theory. So leave at least one page in your notes or observation for theory. You must refer to some electrical circuits or network analysis or network theory textbook to write down the theory. Next, procedure. For hardware experiment, connect the circuit as shown in the figure for frequency response of RL circuit and for frequency response of RC circuit. Set the voltage of the signal from function generator to 1 volt. Vary the frequency of the signal over a wide range in steps and note down the corresponding ammeter readings. So the procedure continues. Draw the graph between gain in decibels and angular frequency for frequency response of RL circuit and for the frequency response of RC circuit. Now, procedure for the software experiment. For software experiment, enter the command window of the MATLAB, create a new M file by selecting file, then later select new and then later select M file. Now type the program and save the program. Execute the program by pressing the tool run and observe the frequency response waveforms. You can pause the video and copy down this procedure in your notes. Next, the formulae for theoretical calculations. Formulae for the frequency response of RL circuit. Inductive reactance XL equal to 2 pi FL. Magnitude formula is M equal to XL by root R square plus XL square. Gain in decibels. G is equal to 20 log base 10 M. Formula for frequency response of RC circuit. Capacitive reactance XC equal to 1 by 2 pi FC. Angular frequency omega equal to 2 pi F. Magnitude M equal to XC root of R square plus XC square. Gain in decibels G equal to 20 log base 10 M. You can pause the video and copy down these formulas in your notes. Now using the above formulas, you can do the calculations. You leave at least one page to do the calculations in your observation. Next, model graph for the frequency response of RL circuit. The model graph is x-axis is omega in radians per second and y-axis is gain in decibels. So this is the plot that you will get for RL frequency response of RL circuit. Similarly, model graph of frequency response of RC circuit. X-axis is omega radians per second and gain in decibels on y-axis. So this is the response, frequency response of RC circuit. Precautions: keep input voltage constant while taking the readings. Avoid loose connections. Avoid parallax error while taking readings. At last, result. So in the result you can write the frequency response of RL and RC circuit for the sinusoidal inputs of different frequencies for hardware as well as MATLAB software were obtained. So thank you for watching this video. If you have any queries, mention in the comment section. If you were able to understand, you can click on the like button. If you want me to make any other video which is related to electrical engineering, you can mention in the comment section. Thank you.